Hello, welcome to episode 2 of my series detailing some of the usage and applications and just some general play with the SimH set of simulators. In this installment, we're going to be looking at installing current NetBSD VAX 6.1.5 version, again on a simulated VAX. So, before this, I have downloaded the NetBSD ISO, and also from now on, in the first video we looked at building the simulators out of Git from source. Done that here. These simulators I built using the Intel C compiler set, which interestingly enough has limited use availability for people who contribute to open source projects. So if you're an open source contributor and you want a really excellent suite of compilers, I would recommend taking a look at it. And also for commercial use, it's not terribly expensive. So let's fire up the simulator. Okay, so we're going to have to set up a few parameters here to get everything we need going. So first we're going to set the CPU, tell it how much memory. We'll give it 256 megs. And we'll set the idle, so the idle loop detection, to NetBSD. There's several idle loop detections for the simulators. Again, here on the VAX, you can use things like NetBSD or VMS. Ultrex, I believe, is another idle loop detection. So let's set the CD-ROM. So we're going to set the type to CD, and let's attach it. Again, you can shorten a lot of these commands. The SimH command prompt is really flexible, really good. The online help system is fantastic. Reminds me a lot of the VMS help system. So let's put on the RQ3 here. Let's put the attach that. Now we're going to create a drive, create a disk for the operating system to be installed in. So we're going to set RQ0. We're going to use the RA user parameter, and this takes the number of megabytes. If you give it the -L flag, you can give it 512 blocks. So we'll create a 5 gig file system. Let's attach that and call it NetBSD disk. Lets me know creating a new file. Another thing we need to do is to attach the NVRAM. This is non-volatile RAM. This will store some parameters of the running system, what your boot flags are, etc. So the VAX is a little more complicated than some of the systems we looked at in the previous video. Okay, we've got our NVRAM file set up. Next thing is attach the Ethernet device. So what we can do is XQ is going to be the Ethernet main type here, and see what devices we have available. See here, Ethernet 0 is my main Ethernet port, my gigabit Ethernet port. Using SimH, I like to have an actual physical interface available for each of my running simulators. And you see Ethernet 1 here and Ethernet 2 available. You also see you can get the TAP and the VDE, so that's virtual device, and then the UDP bridge. So far, I've really had a lot of good success giving it, again, a physical interface. I just use cheap USB 10100 adapters. They're really inexpensive, and the throughput of these simulated machines, you're not going to see an impact by attaching over USB. But also the bridge mode works really well. If you're not on wireless, use the bridge mode. And I'm going to do a video talking specifically about the networking down the road here. So let's give XQ0 Ethernet 2. One caveat here is to do this is using the libpcap, the packet capture library. You're going to need to either be root or set capabilities. So if you're on Linux, look at the setcap and getcap. So the capabilities man page, setcap, and getcap. So you can allow unprivileged users the privileges to do the packet capture. So VAX is interesting versus the other SimH simulators. You can actually boot the CPU, which boots from its firmware. Uh, it'll perform some tests, and we can let's go here at the VAX prompt and see what devices we have. So Ethernet, and we have DUA3. That's going to be the CD-ROM, and DUA0 is our fixed disk hard drive. So let's boot to the ISO image here. Skip that. And this will take a moment or two. And to get fired up, again, we're looking at kind of older systems. It's not going to be the greatest performance here. And you might say, why would you want to use an emulator, and emulating a classic system? There are useful reasons. Hopefully, in production applications, use is few and far between. I like the history of it. It's really exciting for me to learn about these older systems, how they worked, what they had, and their capabilities. But one of the current advantages of this is SimH is one of the best ways to run OpenVMS. Uh, VMS only ran on 3 platforms. So you had the VAX, the Alpha, and the Itanium. And Alpha hardware is a little oddball. VAX hardware obviously is also oddball. And Itanium hardware, again, these are not common bits of hardware today. You can pick up Itanium and Alpha gear on the used market. VAX is a little bit spottier. Again, a lot of the hardware you'll see will be very slow. So let's just step through this. We want the installation messages in English. We're going to throw it on the hard drive. Yeah, we'll continue. It tries to probe the other disks on the controller. We didn't set any up. You can, of course, add other disks to that controller. We'll do a full installation, and we're going to set the sizes. So let's just, for simplicity, we'll give ourselves 256 megs of swap and call it 4 gigs of root. This is not the ideal situation of how to partition a drive or set up your file system. File systems. This is just for the purposes of this video. You can hit accept and give it a chance to review. Ask you for a name. Yeah, we want to continue. And it'll go and throw a file system out on that drive. Again, the performance isn't great, but using the Intel C compilers and what this is currently running on my old laptop is kind of my home server now. I'm getting about 37 VUPS. That's VAX unit of performance, which is in line with the kind of later era, at least workstation style VAXs, to get about 37 to 38 VUPS. So while it's slow, it's going to be late 90s kind of workstation slow. It's not going to be 80s era slow. So I'm going to install from the CD, and let's continue here. And this is going to go and install. This will take a little bit of time to go bring everything out. A little bit about the VAX. The VAX was Digital Equipment Corporation's follow-on to the PDP-11, so a mini computer. In fact, the first VAXs, so the things like the 11780, actually had the capabilities to run PDP-11 software. Now VAX stands for Virtual Address Extension, so they had specialized hardware to do paging. They had a 4 gig address space, so full 32-bit addressing, which was pretty big for the time, which was kind of the late 70s when they came out. And VMS was the operating system that went along with it. But a lot of people in those early days ran Unix, so the Berkeley distribution was really targeted to the VAXs when they became networkable, and that was one of the the primary uses for the VAX. I'm going to stop the recording here and pick up in a little bit, because this will take a little bit of time to install, and we'll pick back up with the configuration. Okay, we are back. All the sets have been extracted to the root file system, and boot disk, boot box have been installed. So let's move on to configuring the system. Important thing to do is the network. QT0, that's our XQ 0 interface we set up in the SimH configuration. Default media type. We'll take DHCP just for the time being. We get an answer back proving that Ethernet is working, or the networking is working. You could set up static as well. Well, let's throw in anything here. Call it something useful. It's going to set up some routes. And again, as I mentioned before, this isn't the speediest process. Very modern operating system. So in the Open VMS world, the latest version you can get that'll run on the VAX is going to be version 7.3, which is one major version back from what's current on the Itaniums and the Alpha. Give it a password. Not a very secure password, but this is just on my my local network here. Another point, you could actually set up multiple interfaces if you had enough of them, or using bridged interfaces. And again, we'll talk about bridged interfaces in a later video. The next thing to do is to get the package set up. So one thing to note, the latest package directory for NetBSD VAX is 6.0. So I'll have to edit this here. 6.0 will be a symlink, I think, to 6.03 or 6.04. And this will take a moment to pull down the package information, and we'll probably get a warning about it. See, it was built for 6.04. And this will just let us get some packages installed if we need it. So kind of an important step. You could also do package source. Again, because this is a slower system, building from source is not necessarily what I would do if a package was available. Now, some of the other BSDs, like OpenBSD, which is your other choice here on the VAX. I think FreeBSD at one point did support the VAX, but they've kind of, I think, moved that to a lower tier of support. I don't know if it's even still available. OpenBSD is another good option. I find NetBSD is a little bit smaller and faster on such limited hardware, but I'd prefer OpenBSD. I know it's a toss-up. Depends on what I was doing with it. They're both great operating systems, and if my work didn't require stuff like Java and some of the stuff that's really Linux only, I would run the BSDs more. The NetBSD and OpenBSD work incredibly well on laptops, modern laptops, incredibly well as desktop operating systems. They're really lightweight and nimble. FreeBSD as well, and that may be a more gentle introduction for some users, in that it may be a little more hand-holding. But again, OpenBSD and NetBSD, they're available for a variety of platforms. And FreeBSD is a little bit more limited. So that is now finished, and we are done here. So we'll now get back and exit, and we'll shut down here. Okay, now that we're halted, let's take a look at creating the initialization file so we can bring this back up quickly. I remind myself of the file names, and let's create the initialization file. As I said before, if you name the INI file the name of the simulator, it'll pick it up automatically. So we set our CPU for 256 megs. Uh, idle detection. Um, next thing would be to attach our non-volatile RAM. And attach our main disk and network. So there we go with the basic setup. So let's fire up the simulator again. Forgot a couple things in the simulation file, but let's boot into the machine console here, and we'll set up what the default boot device is. So the boot device is currently set for the network. So it's now set to the first disk. Control E brings you back to the simulator prompt, and exit. Let's go back in here to Emacs. So we're going to put a 0 in the boot device register to tell it to auto boot, and I'm going to boot CPU. So now we should be auto booting straight into DUA 0, the disk device 0, NetBSD. So let's see if this works. And it does. Let's skip that. And let's just also see if the networking works once we get in there. So as for the next video in this series, I'm thinking I'm going to do start in either on the OpenVMS set, and it'll take some more time to cover that. That's going to be a bit more complicated. And part of the reason it's going to be more complicated is I'm new to OpenVMS. So you'll see a lot of mistakes. Of course, I make a lot of mistakes here. I'm nervous about recording what I'm typing, but I'll make even more mistakes on the OpenBSD, or the OpenVMS, I should say, side. And I'm kind of debating. So it'll either be, the next one will either be me going into OpenVMS, or I'll start taking a look at some of the more obscure PDP-11 and PDP-8 operating systems, things like maybe CAPS-11 or RT-11, one of the single-user, multi-user, mini computer operating systems, or maybe something on the Nova. It's either that or go straight into OpenVMS on the VAX. And OpenVMS is a lot to cover. Probably could do 2 of the smaller operating systems for the PDP-11 in one video, whereas it will take at least 2 to 3 videos to cover OpenVMS, just because it is a more involved. It's a big, complicated system, and the install process is, again, for me, coming from a Unix and Linux background, the install procedure is a little different. Not to say it's difficult, but there's simple things in OpenVMS are a little different, like changing directory. After 30 years, it gets hammered into your brain that cd ... takes you to the parent. Where in OpenVMS, it's set default square bracket minus signed and square bracket to go up to the parent. It's a bit of a change. So like I say, we'll see what the next video comes out, what that's going to be, whether it'll be the start of the sub-series on OpenVMS or something fun. If anyone's actually watching these videos, which I doubt, leave a comment. Say what you'd want to see. And again, once the SimH series is going to be done, maybe touch on some other stuff, related to other emulators. looking at an Alpha emulator, again for VMS, looking at some Commodore emulation. Commodore 64 and 128, great home computers of the 80s. Um, you can look at those with the Vice emulator, and that'll do everything from PETs all the way up to C128. What is should be considered the best of the 8-bit home computers. Even play around a little bit with the Apple stuff. I'm not terribly familiar with the Apple II series. Maybe a little of the Amiga UAE or WinUAE. Um, and I am kind of droning on at this point, waiting for the font config cache to update. And as I've been saying throughout this video, these are not the speediest machines. And this is currently running on I think it's a 3.3 or 3.2 gigahertz i7 laptop processor. And the latest version of SimH, the version 4, actually does some threading. If I'm not mistaken, if that's incorrect, don't hold it against me. But it should do threading to offload things like disk and an I/O interaction. But again, because modern I/O systems are so fast, that's not going to buy you a whole lot. And what I'd like to see for kind of the next generation of SimH, or maybe the next version, is multiprocessor support for the VAX. I mean, a lot of these machines here are uniprocessor only, but to see that multiprocessor support in place, because VMS should support multiple processors, which would be great to see. And I seem to remember that there was someone who had a modification of SimH to do that, but it may have not been fully compatible with all the other bits and pieces there. So again, SimH, if that would be a kind of something to put on the roadmap there. Some of the other emulators you can look at, there are some other commercial emulators for the VAX, and for some of these other machines. I like to stay away from them. One, because some of them are Windows only, and I currently don't have a Windows environment to use. Second, for the purposes of just hobby use, an open source emulator works just fine, and that you can go in and fix anything that's broken. Not that I have not found a single bug in SimH in several years of using it. So it's really stable software. And again, since it's moved on to GitHub, there's been quite a bit of activity for bringing things up to date and adding new features. One of the best new features in the latest one is an expect and send interaction, so you can actually, like the expect language, you can actually expect interaction and send back data to and from a running emulator, which is great. And some other conditional stuff. So it looks like we are finally booting up here. So I really want to show off is just that this is a real working system here, and that you can get out on the network, which will be good. Again, networking, probably need to devote an entire video to networking in SimH, because there are some confusions, some different ways of doing it. Like I say, I like to use a hardware interface for each of my emulated interfaces, but you can use the TUNTAP or abridged interface, and you can use VDE. So VDE is a virtual kind of virtual networking for Linux. So see here, let's say YouTube, and so network connectivity works. And how much space did we take up with a full install? 482 megs. So again, NetBSD is nice, small, and lightweight. No Perl. So you can install packages at this point, but I won't do that. In fact, I'm probably going to sign off this video because you heard me talk long enough, but those are kind of the instructions for setting up NetBSD, the current NetBSD, on the SimH VAX simulator. Thanks for watching and listening, and look forward to the next installment.